Imagine you're a field biologist. It is 4:30 in the morning on a winter day, and you're about to conduct your fieldwork. You have your data sheets and notebook in one hand, and a handheld spotlight in the other. Your mission is to walk an 800-meter transect while looking out for wallabies using your spotlight. Oh, there's one right on the track. You quickly reach into your pocket to grab your pen and your GPS unit while trying to flip open your notebook to record your observation. And don't forget, you still have your spotlight in one hand. Right at this moment, you heard a loud thud and see another wallaby hop across the track. Sounds very chaotic, right? Now, I want you to put yourself in another scenario. You are still a field biologist, and you are still, unfortunately, carrying out your fieldwork at 4:30 a.m. on a winter day. This time, though, you are using a drone. What does that mean for you and your work? It means you don't have to walk an 800-meter transect while carrying loads of stuff. It means you can control your drones with a pre-programmed flight path application. It means you can sit on a folding chair, make yourself cozy, sip on hot chocolate, while monitor your drone location on your tablet. Perfect. That's my kind of science. For my doctorate at the University of Tasmania, I'm studying how to deploy drone technology to count megapods. Megapod is a family of pouched mammals, which include kangaroos, pademelons, and wallabies. Coupled with machine learning, I'm hoping to make the essential fieldwork of documenting these animals more efficient and accurate. Before I dive into the topic of wildlife conservation using drones, let us learn a little more about drones. Drones are often known as unmanned aircraft systems, or UAS. A drone is operated either remote control by the human operator or via an onboard computer using a pre-programmed flight path. There are 4 major types of drones. You have fixed-wing, single-rotor helicopters, multi-rotor, and fixed-wing vertical takeoff and landing drones. The ones that you can purchase off the shelf are usually one of the varieties of multi-rotor. Most drones are equipped with aerial photography systems and artificial intelligence software that allows the operator to program a mission, or more simply, decide where the drones will go. There are other extras often included, including GPS receivers for live data, and onboard sensors such as multi-camera navigation system that helps drone to avoid obstacles and to hover without a GPS. Now that you know a little more about drones, I want you to think about where you most associate them being used. For many of you, I believe that association might lead you to imagine people taking annoying photographs, spying on their neighbors, and flying to places without clearance. Or you might have heard of drones being used in search and rescue operations and to deliver medical supplies. But what about their use in wildlife monitoring? Wildlife monitoring is a crucial component of conservation. We need to be able to take reliable surveys in the field to predict future trends and to understand the viability of wildlife populations. Usually that is done by counting and estimating numbers of animals. Why is that important? Well, changes in numbers can tell us a lot about what is happening out there in the field. It can tell us about predatory behavior and whether there has been disease transmission, for example. Both of those things, among others, are fundamental to the conservation, research, and management of wildlife conservation. There are numerous examples of the use of drones to survey both land and sea mammal populations. They can help intervene in fighting against poachers by providing both photographs and videos. And they allow environmental activists to track whalers using GPS coordinates. Drone surveys also serve as a tool to shepherd wild animals away from dangerous situations. For example, rangers from Mara Elephant Project in Kenya use the buzzing sound of drone to drive elephants away from farmlands without causing risk to the animals or people. The sound of a flying drone, very similar to a swarm of bees, evokes an immediate flight response from elephants, leading them away from farmlands and ultimately reduce conflict between elephants and humans. There are many advantages in using drones for wildlife conservation. Drone surveys are more cost-effective and safer compared to manned aerial surveys. Researchers can collect large volumes of image-based data from a wide variety of habitats, including those that are difficult to access on foot or by plane. An example of that is seen in study of cliff nesting bird species, such as Cape vulture, which would be almost impossible to collect otherwise. Drone surveys are also more reliable compared to ground-based survey techniques, as humans make more errors on the ground than drones in the air. Drone imagery can be reviewed in real time by remote pilot using a constant stream of video footage, and this allows what is seen of a species, it's more likely to be accurate. A permanent record of images and videos allows future consultation with other wildlife experts, and this increases the accuracy of species identification even long after the survey has been done. But what about how the animals themselves respond to the use of drones by researchers? Luckily, we have studies that show us how a number of species respond to the use of this form of surveying. Large sea mammals such as humpback whales and southern right whales show no behavioral changes towards drones, even during close-up approaches as low as 10 meters. Some land mammals have been shown to be hypervigilant towards drones. Remember the African elephant that I mentioned earlier? These animals might associate drone engine sounds to bees or biting flies. And that is why rangers in Kenya are able to use drone engine sound to drive elephants away from farms. A group of researchers in France revealed that there were no behavioral changes in a number of bird species, including wild flamingos, during most approaches when drones were flown at different angles. And drones could be flown as close as 4 meters to these birds. Researchers found that large birds or flightless birds are the most sensitive to drones, whereas land mammals show less behavioral changes towards drones, with sea animals being the least affected species. What about my study on megapods? To date, there is only one published research on the study of how megapods behave towards drones. Researchers from the University of Sunshine Coast found out that forested kangaroos in cities and outskirts are most likely to flee when drones were operated overhead at an altitude of 30 meters. It is suggested that an altitude of 60 to 100 meters will minimize disturbance and behavioral impacts on forested kangaroos. My studies suggest that Bennett's wallabies and Tasmanian pademelons react to drone engine sound rather than drone size or color. The altitude that best balances the need to get high-resolution images and low disturbance to Bennett's wallaby and Tasmanian pademelon populations is 50 to 60 meters. The use of drones sounds like the perfect solution for wildlife conservation, doesn't it? Well, most of the time. Although they are powerful and cost-effective, in some situations, ground-based survey techniques such as walk-line transect surveys might still be the best approach. As a drone pilot, we are still limited by poor weather. I mean, you can't fly a drone when it's raining or windy, can you? Drone surveys also produce a two-dimensional view of the study area, where rocks and trees might affect what is seen because animals might have taken cover. On the other hand, walk-line transect surveys give us a 3D view of the study location, which allows researchers to see those animals that are hiding under trees or rock covers. How do we fix that? Well, we can mount a thermal imaging camera on drones, which helps to detect warm-blooded animals, even in 2D views of the study area. We also have to be careful when flying a drone during bird breeding season, as some species may get territorial. Although it's rare, we have seen birds like wedge-tailed eagles attacking drones in Western Australia. Bird-drone interaction can be prevented by operating your drone at certain times of the day or during certain periods of the year. So, where does that leave us in the use of drones for wildlife conservation? Very different to the use of drones by your pesky neighbors. Using drones and their associated technology to study and protect wildlife is transforming the way field biologists collect data. It is an exciting time for animal ecology, and one that I hope all of us, as part of the ecosystem, will be there to witness. Thank you.